So let's explain all of this with an actual reader-writer example. The actual shared file is accessed via these read data and write data operations. As we see, these read data and write data operations are outside of any log construct, both in the case of the readers as well as of the writers. So what that means is that the actual access to the file is not really controlled. Instead, what we do is we introduce this helper variable, resource counter, and then we make sure that in our code on both the readers and the writers side, before we perform the read operation, we first perform a controlled operation in which the resource counter is updated. Similarly, on the writer side, before we write, we have to make sure that first a resource counter is set to -1. Now that the changes to this proxy variable, that will be what will be controlled, that will be what will be protected within the lock operations. Once we are done with the actual shared resource access, with reading the file or writing the file, we again go into these log blocks. This is where we update the resource counter value to reflect that the resource is now free, that this one reader finished accessing it, or that no writer is currently accessing the resource. So what we'll need basically in our program, we will need a mutex, that's the counter mutex. This is the mutex that will always have to be acquired whenever the resource counter variable is accessed. And then we will also need two variables, read face and write face, which will tell us whether the readers or the writers need to go next. So let's explain this. Let's see what happens when the very first reader tries to access the file. The reader will come in, it will log the mutex, it will check what the resource counter value is, and it will be 0. That's what the resource counter was initialized as. So it is not -1, perfect. We continue to the next operation, we increment resource counter. Resource counter will now have a value of 1. And then we unlock the mutex and we proceed accessing the file. A subsequent reader comes in, and let's say while it's executing this operation, before it came to the unlock statement, the next reader comes in. The next reader, when it comes in, it will see that it cannot proceed with the lock operation, so it will be blocked on the lock operation. So this way, basically, we are protecting how resource counter gets updated. So only one thread at a time, both on the readers and the writers side, will be able to update to access this resource counter. However, let's say when that second reader came to the unlock operation, it will be able to join the first reader in this read data portion of the code. So we will have two threads at the same time reading the file. Now let's say a writer thread now comes in. So the writer logs the mutex, let's say the mutex is now free, and it checks the resource counter value. The resource counter value will have some positive number. We already allowed some number of readers to be accessing it, so it will be, let's say, 2. So clearly the writer has to wait. Now it will wait. In the wait operation, it specifies the counter mutex, and it says it's going to wait for the write phase. What will happen at this point, remember, we are performing this wait operation within the lock construct, so the writer has the counter mutex. It's the owner of the counter mutex. However, when it enters the wait operation, the mutex is automatically released. So the writer is somewhere suspended on a queue that's associated with the write phase condition variable, and the mutex is at this point free.